Hello and welcome back to Calculus 2. This is section 8.3, part 2 on trigonometric substitution. So last time, trigonometric integrals. No, not substitution, that's next. Trigonometric integrals. So last time we said we had a few of these formulas that you must know. And then we talked about trig pairing and we paired sines with cosines. And when you are working on a sine-cosine pair, you can have two flavors of the problem. One of those is to have sine both have even exponents, and that's the one that it's scary, or both of them to have at least one to be odd. Now, if you have the odd situation, which is the example here, then whichever term has an odd, or if they both have, just pick one, you peel off a single cosine in this case, and you leave that together with dx as a unit for du when you do your u sub. So it's a very simple, straightforward trick when you have an odd exponent. Here's another example with two odd exponents, and then we just picked one, which was in this case sine, and then worked out the entire problem that way. And then we had sine and cosine, both exponents even, and that was a journey, right, to calculate. And we got it at the end. I mean, it took some doing, lots and lots and lots of those power-reducing formulas. Anytime you see a sine or cosine squared, you have to hit it with that formula to get rid of those squares. The goal for today is to work on secant tangent pair. So that's the goal for today. And in order for you to survive this one, you must know that the derivative of secant x is secant x tangent x, and the derivative of tangent x is secant squared x. Why is this important? Because your u's are going to be there and your du's are going to be here. And that's why this is so important. So let's take a look at an example. Say you have, we'll do something something simple that you should be able to do just by looking at the problem. Integral of 10 tangent to the 9x secant squared x dx. So secant tangent pair doesn't have the issue with odd and even exponents and all that, because you guys have the red derivative definitions or calculations, and you just get to use that. So when you look at this up there, you see that the derivative of tangent is secant squared. Great, you have secant squared, right? So this problem is actually already set up for u sub immediately, because if you say u is equal to tangent x and du is equal to secant squared x dx, you already have secant squared x dx in here. So you kick 10 outside, integral of u to the 9 du, because this part here is du. And this is going to be u to the 10 plus c, because right over 10 would cancel with this 10 here, so they're canceled both. And now you can use, well, no, first we put back into tangent. So tangent to the 10th power x plus c. So that's our answer. Hey. What else we can? All right, problem 30. Oh, come on. There we go. Problem 30. Integral of tangent cube theta d theta. What are your thoughts? Can we integrate tangent cube directly? No. Good. Can we use u sub right off the bat? Correct answer is no. Why? I see 3 of you shake your heads no. Okay, I agree.
There's nothing to sub.
There's not, yeah. So if you say the tangent is u, then what do you need for du?
Secant tangent. Secant squared.
Secant squared. We don't have a secant squared. Or do we?
If we take one off.
Ah, you take one tangent off and you have tangent squared. And tangent squared can be, by use of magic called identity, can be transferred into secant squared, right? So you are not supposed to lose the sight of the formula 1 plus tangent squared x equals secant squared x. Because you need that knowledge to move the tangents into secants so you have enough building blocks for the rest of the problem. So great. We are going to peel off one tangent. So I have tangent squared theta times tangent theta d theta. So this is what I have. And then we are going to transfer this one into secant squared theta minus 1. And then we will have 2 integrals to worry about. So we have the first integral is secant squared theta tangent theta d theta minus the integral of tangent theta d theta. Do we all see this? So you have the red secant squared. Secant squared times tangent, that's one integral, and then 1 times tangent is the second integral. We can break them apart because you have a minus sign, right? You cannot break multiplication, division, and so on, but you can break into multiple integrals if you have additional subtraction. So now we have this, and we now just integrate. The first integral has u substitution, right? U is tangent, and then du is secant squared. So this one would be u equals tangent theta, du equals secant squared theta d theta. And we have all of the ingredients to make that substitution and so on. So this becomes integral of u du, and eventually it will become 1/2 u squared. That's eventually. And now minus, and for this one, what should we do here? Did you just say integrate? Okay, sure. How? 100% of what you said was correct, by the way.
By math.
Wait, what?
Integrate by math. By
Integrate by math.
By calculus.
Calculus-based math. Great. It always reminds me of a particular character from my high school. This guy was always sleeping in class. Always sleeping in class, never paying attention. His family owned a private business, and then he was also into cars and gangster stuff. So he never had a chance to study, and then he slept a little because he would be out all night, right? So he sleeps in class. And then teachers would pick on him because he was sleeping in class and asking questions, right? It was funny, I think he always bursts with confidence, repeats the question, and then goes to a screeching halt. It would be something like this. So how do you integrate tangent theta? You integrate the tangent theta by... And that's it.
Just enough attention.
Yes, it's just like so much energy to answer the question, and it just dies. It's a clip down. So let's see. What do we do for tangent? We did it in class. I know. We did this in class. It's not a basic integral, so
Sine over cosine.
Sine over cosine, and then use u sub, right, to eventually get the ln. So this substitution is going to be orange. So tangent is sine over cosine. We have u equal cosine theta, du equal negative sine theta d theta, because tangent is sine over cosine. So now we have that one. Oh, I wanted to move around, but I can't because there's no power. I gotta sit here. So that's the. You know what? Let's make this blue. And now we have the orange. No, blue. Q. Oh, there we go. And now we have the other one, which says integral, and it's sine over cosine. So it's going to be a negative du over u. Maybe I should use a g. Let's use g. So it's dg over g. G substitution. I'm not sure if you worked with the g substitution before. It's the same as u, it's just using a different letter. So now to integrate these, there is a plus, and this becomes ln of g, everything plus c. 1/2 tangent squared theta plus ln of g. G is cosine, so ln of cosine theta plus c. Now, technically, you are done, right? But then you look at this and you say, I want to work on this a little bit more, because you have a tangent and a cosine in the answer. Can we change this cosine into a secant somehow? And the answer is yes, because cosine x is 1 over secant x. And if I flip it, 1 over cosine x is equal to secant x. So 1/2 tangent squared theta plus ln of 1 over secant x plus c. Now, this could be it, but we can still make it better by stealing a minus sign from a plus, and then that would flip the fraction inside. So, so 1/2 tangent squared theta minus ln of secant x. Wait, I have thetas and x's. It's supposed to be thetas everywhere, right? Thetas, there we go, theta, plus c. So that will be the best answer, because now the functions are aligned. So I stole a minus sign from that plus in front of ln. I stole a minus to, people usually say borrow. Well, I'm not intending on returning it ever, so I stole a minus sign. So stole a minus sign from here, and that goes as a -1 in front of ln, which jumps as the exponent of -1, and what the exponents of -1 do is they flip the fraction. So secant theta became the top. And now the problem is solved, and the problem is problem is solved. That's it. Yes?
Is it possible to solve these equations by parts?
In some cases, you have to, yes. Just like when you learn the product rule, chain rule sneaks in. You learn, right, the chain rule. You learn any other rule, other methods sneak in. Some of you in this class, right, for some of you it's going to be sad news, and for others it'll be good news. I lost the problem where you have to use 6 methods of integration to solve it. Because you start solving one method, and then, how integration by parts spits out something else. Then you have to use something else there. And then eventually, right, going through all this, let's say, integration by parts first, and then that leads into trig sub of some sort, and then trig sub leads into partial fraction decomposition, and the partial fraction decomposition is the basic u sub. So it just goes down the line and branches off, and you finally have the answer. I can't find that problem anywhere, so I'm really sad. But maybe I should sit and create one, just because we can. So this was the secant tangent problem, where you have a secant squared as your substitution. You keep secant squared for substitution for du. Now the next batch of problems is where you actually have to save secant tangent for du. None of these problems are easy to spot. You actually have to develop intuition, and you have to practice a lot in order for it to click in. This is a nice problem, I think, I hope. Integral of tangent x secant cubed x dx. So try this one on your own, you know the basic step. Any ideas? split one secant, and then what? Yes, split one secant off and then use sub immediately. Right? Split one secant and use sub immediately. Fundamental theorem calculus. Limit definition. It's calculus one, isn't it? Calculus. It's not yours, unfortunately. Oh, that's so cute. I think I saved one. No, it's fine. Anyway. So we split one of the secants. Tangent x secant squared x secant x dx. Why? Why do we split one? And how do we do use sub immediately? Well, the derivative of secant is secant tangent. So all of this is going to be du. For the substitution, u equal secant x, du equal secant x tangent x dx. So the problem simplifies into u squared du, which is u cubed over 3 plus c, and then 1/3 secant cubed x plus c. Remember how I said, you know, if you care, you can check. You just take a quick derivative. You take the derivative, the 3 drops in front, fills the fraction, and it's gone. So you're left with secant squared. Now that's something squared. So the derivative of secant inside is secant tangent. So secant times secant squared is secant cubed times tangent. Good to go. So. We can also take a look at the non-awesome problems. It's all fun and games. Someone loses an eye, right? Okay, so integral 0 to pi over 4 of secant to the 4 theta d theta. So try to break your head a little bit. Any ideas?
What is the secant squared times secant squared? None that I need to be 1 plus tangent squared times secant squared.
Okay.
I got stuck with
Where did you get stuck?
algebra. Pretty much after that, I don't know which path would be best for distributing.
Well, there's only one way to distribute. So your idea is to write two secants and then transfer one of the secants, right? So you want this one to be 1 plus tangent squared. And then when you break this into two integrals, you get integral of secant squared theta d theta plus integral of tangent squared theta secant squared theta d theta. Does that make sense? All right. So what is the integral of secant squared? That's a basic integral that you are supposed to know from 4.9. Tangent. Plus, and now this puppy over here has its own u sub, right? U equals tangent theta, du equals secant squared theta d theta. So this part is going to be u squared, so 1/3 u cubed plus c, and we need to fill that in. So tangent theta plus 1/3 tangent cubed theta plus c. So breaking this into secant squared times secant squared was the key, and then transferring one of these into the tangents, because you need to work tangent with secant squared and then secant with secant tangent. The question is, do you have, right, how many powers of tangent you have and all that kind of stuff. Again, practice, 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 practice. And then when you're bored, do just one more problem, and then that's it. Right, it's the way it goes. Let's open the gates of hell, but just like an inch. Just to peek inside, and then close it right after the problem. Secant cubed theta d theta. Oh, the previous one was the definite integral. 0 to power of 4. There we go. Yeah, and you just walk away. You know, just back it up slowly, back it up, and you're done, right? It's like, all right, good. It's plus C now. This problem, too spicy. I was worried to put this problem on a tablet that was overheated to begin with. Now, let's see. Been teaching Calc2 for 10 years now. One of the favorite phrases before the second exam. Can we please have no secant cubed on the test? But put anything else. Okay.
sine squared over cosine squared.
I heard over, so it's wrong.
No?
Gotta take it different.
We're gonna have time to do the lab today.
Hopefully, is
Yeah.
like we have to do. After this is a secant, cosecant, cotangent pair, right? Which is going to be the same as this one, you just have minus signs. So that's like, if you know this pair, you know the other pair just has a minus sign. That's good. Right? We don't have to relearn anything. So it's either sine, cosine, or secant, tangent. Cosecant, cotangent, you just put the minus sign. You're good. Figuring this one out. Spice. Any ideas?
About 1 over cosine cubed.
Let's not involve cosines at all. It's not going to be cosines and sines at all. That's definitely the first step. Peel one off. But then, what then? Tan-tan. There's the scary part.
So we start by peeling off a secant, and we have secant theta, secant squared theta d theta. Great, we have this, right? But then you go and say, if I am to keep secant squared in a bank for du, I need to have tangent for u. But there is no way to transfer single secant into a tangent. So that's a dead end, right? Then you say, well, if it's not a secant squared, then it must be secant tangent, right? For the bank. Because it's either, right, when you take a look at the basic formulas for derivatives, it's either secant tangent in a bank or a secant squared in a bank. One of those two has to be in a bank for du, and then the u is whatever is in the parentheses. Either way you look, you are always short tangents. Either way you look. If you put secant squared into the bank, then the secant this secant needs to be some kind of tangent, but there's no way you can transfer this into a tangent, so dead end. If you transfer this into a tangent by writing 1 plus tangent squared, and then you distribute, you might be able to do something with a half of the integral, the other half won't work. And I see some of you are shaking your heads because you tried that. So, right? Neither of the two works. Now, what was that saying which I told you last class? Yeah, when in doubt, integrates by parts. See, be careful what you wish for. Who said, how about integration by parts within trig? Well, there you go. All right? So, integration by parts. We can integrate secant squared, and we are happy about that. So, we're going to keep that for a dv. So, u is secant theta, and dv is the secant squared theta d theta. So hopefully this works. And I said hopefully. du is derivative of secant is secant theta tangent theta d theta, and the integral of secant squared is tangent theta. And we put our trusty arrow. So now we have secant theta tangent theta minus the integral of secant theta tangent squared theta d theta. Now what? Again, you are looking for secant square in a bank. We don't have secant square. Then you're looking for secant tangent. If you peel off one tangent and you put secant tangent in a bank, you need to have secants, but you have a tangent. And there's no way to go from that single tangent into a secant.
Integrate by parts again.
Integrate by parts again. Let's see. Hopefully that works. Now, what would I pick for this time? U and dv. So what can I integrate? Well, I can integrate secant tangent, right? So let's try that one. Secant theta, tangent theta d theta, and over here I have tangent theta. So this is going to be du is equal to secant squared theta d theta, and over here we have that v is secant theta. Let's put the arrow and see if that helps. Don't forget to copy the secant theta tangent theta we started with, minus, and now in parentheses we have secant theta tangent theta. Oh, we are back to the beginning.
That's a good thing, right?
It's not.
Can we do that thing where we...
Well, it's not that, because look what happens. These guys cancel, minus and minus is a plus, and you get secant cube equals secant cube. So, I know, right? But we are not... See, this is why I said we peek a little bit. We don't want to make it too hot, right? You peek a little bit to close the door right away. So that's not the way to go about it now. What now? So this won't work. Okay, great. We found a way it doesn't work. So we're not going to go that way. We'll have to do something else. Can we straight up just transfer this into secants and then maybe the trick will work? I don't know. Maybe it will work.
We're going to get secant.
Yeah, but I hope it's a minus secant cube so that I can add it to the other side. Because if it's a plus secant cube, then I have a positive one on one and positive on the other. They cancel. But if I have a negative secant cube, then I can move that one to the other side and make 2 and then divide by 2. I don't know. I'm guessing. Let's see. So secant theta, tangent theta, minus. And now I have secant theta. And instead of tangent squared, what do I have? Tangent squared, it's 1 minus secant, right? Not good. Not good again. You see that? Because the minus from here and the minus from here will create secant cubed and will work again. Beautiful. At this point, right, nothing works in a problem. We should just walk away, right? No. It's just to demonstrate how interesting this can get. Where my definition of interesting and your definition of interesting might not align perfectly, but nevertheless is the word. All right, think about it. 1 second. So is it solved? No? Aw. This is a lot of fun. So what happened when you hit the dead end, right? You can backtrack and see if you can do something different earlier. Like, is there anything that we could have done earlier in the blue substitution that could have gone the other way? Can we maybe change this secant into tangents and then multiply and then deal with the remaining integrals that way? So this is the beauty of these, right, difficult problems, because it makes you think a lot. So I split one secant theta and then the other secant theta is 1 plus tangent squared theta d theta. So we can try this way now. I have two integrals. One is integral of secant theta d theta, and that one is bad on its own because you need to know that trick from Calc 1 to integrate if you don't have it memorized. A lot of people memorize it. It's just ln of secant plus tangent, so you don't have to go through the horror of solving it. Plus, the other integral now is secant theta tangent squared theta d theta, and maybe the u sub, not the u sub, the by parts would work in this case, right? So you have a secant tangent which you can integrate, so that's going to be your dv. You always put dv first because that is something that you can integrate. And you see now that for u, you just have a tangent left because the rest is in a dv. Now u is going to give us du for secant squared theta, and v is equal to integral of secant and is secant theta. Oh, there's a detail over here. Derivative of tangent is secant squared. Good. So let's see if this helps. Integral of secant theta d theta plus, and now I have secant theta tangent theta minus the integral of secant cubed theta d theta, and there it is. Finally, we got minus secant cubed. This is the one that you get to ship to the other side. So send to the other side, and what you get here is going to be two integrals of secant cubed theta d theta is equal to integral secant theta d theta plus secant theta tangent theta, you can say plus c, and divide by 2. So integral of secant cubed theta d theta is equal to, now I did tell you that this one is ln of absolute secant theta plus tangent theta. That's a whole different issue on how to solve that one, which you are supposed to know from Calc 1. Now, I understand that most of the people don't know it. Oh, I forgot a half. Sorry. I forgot a half because this 2, that's the reason why we're doing this. 1/2 in front, right there. 1/2 in front, and then 1/2 of this, plus this is already solved. Secant theta, tangent theta, and then plus c, and we're done. Welcome to Calculus 2. Now, the next time there is some kind of family gathering or something, you should lead with this. When they ask you, what's new with you? Well, that's the idea. More time for video games. Do you see that we actually abandoned this problem completely? It started okay, it looked good, we got to this point, and we tried 3 or 4 different things, and nothing worked. Right? So it's not just abandoning this one step that didn't work. We actually had to abandon actually this one that did work, because if we rearrange it in a different way and still use the same method, right? So this is over here under try again, but take a different path. And this is why math is so good and prepares people for those heavy tasks in thinking, because you get to realize, right, that you made a mistake, and conquering this problem, guys, is actually a big achievement. I did mention already once in class, anything that you are able to accomplish on a first shot is not special. and you cannot really hold it as something special, right? You have to fail and show struggle because when things are easy, everyone can do it, and then they're not special. That's one of the things. So, right, when I welcome you to the 1%, welcome to 1% by sitting in this class, because 1% of students here take this class, right? Welcome to the top 1%. You know what I mean? I know. And then the next course, either DFQ or Calc3, pick is top 0.5%. And that's your competition, right? Now is algebra, elementary algebra? No, 100% of students. And that's why it's not so special. It used to be special 500 years ago when 7 people understood it, right? But now, no. Everyone is supposed to be able to do it. So this is the part that makes you special. Great. Now the last part of this is going to be the cotangent, cosecant part. And it's going to be the same steps, same ideas, same Pythagorean identity. Everything is the same, except when you do integrals and derivatives, you have minus signs that you need to worry about. So all of the techniques, all of the ideas and thinking, everything is identical to secant tangent. You just worry about negative signs. So welcome to the cosecant cotangent pair, where we have that the derivative of cosecant x is negative cosecant x cotangent x, and where we have that the derivative of cotangent x is negative cosecant squared x. So these are the ones, and again you have the same idea. If you are keeping this in a bank for DU, these must be your U's. It's absolutely the same. You just need to have the minus sign, floating about. That's all the difference between the two. Now, I'm going to end this lecture because the next lecture is trigonometric substitution, which means you are turning a non-trig integrals into trig integrals, and then you use trig integrals to solve them. So we will be practicing all of this again in the next section in every integral, because the method is to turn a non-trigonometric function into a trigonometric functions, integrals, and then apply these methods to solve. So there is no need to go and do another 7,000 problems, because we will do more examples in the next section. So let's take a 5, and then when we come back, trigonometric substitution.